Hamilton theorem. Way is only the statement they may ask you in exam. Another way, the verification of Cayley Hamilton theorem. So we start our class by writing their statement here first of all. Statement. Statement. Are you doing the practice daily?
Yes, sir.
Okay. So how the statement will be? A single line statement is there. Single line only. Every square matrix satisfies every square means either 3 by 3 or 2 by 2. Square matrix satisfies its its own characteristic equation. Its own characteristic every square matrix satisfies its own characteristic equation. This is the statement. So now you may have a question that what is the characteristic equation and how to find out. Square matrix that you know, a row and columns are equal, and mostly we are using 3 by 3 matrix. Okay. So now how the verification will come and how the question will ask in exam. So question will be verify Cayley 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 Hamilton theorem. Verify Cayley Hamilton theorem. For Cayley Hamilton theorem for here one matrix is given. Capital A is equal to 7, 2, -2, -6, -1, 2, 6, 2, -1. Tell me what is the order of this matrix?
3 by 3.
3 rows, 3 columns. So if it is a square matrix, definitely this matrix satisfies its own characteristic equation. So the work will start from here like that. The characteristic equation. Yesterday also we did characteristic equation, right? We are getting some lambda value.
Yeah.
Yes. The characteristic equation of capital A is this one. Yesterday we have already completed this. A minus lambda I is equals to 0. So there is a change only. Where is the change? Change is only for the diagonal element. 7 minus lambda. 2 minus 2, we don't want to change anything. -6 itself as it is. Only the change in diagonal element. You understand this?
Yes,
We
sir.
need not to waste our time by writing A separately, then multiplying lambda with the identity matrix. We don't want to waste our time. Simply the change will come in diagonal after doing all this process. So better to start here only. Plus, minus, plus is the rule. So working on this implies if you consider 7 minus lambda, and we know that corresponding row and column we have to neglect. It is -1 minus lambda, even though it is also -1 minus lambda. So together becomes whole square. -2 to the 4. If you don't understand, you can make it separate also. You'll get the same thing.
Yeah.
And second element -2, then column and row will be neglected. -6 into -1 minus lambda. This is AD. Okay. Column and row. This into this -6 to the 12. Then bracket close. Last element with minus sign, because here plus into minus minus will be there. Column and row neglect. It is minus 12 minus 6 into 1. No, notice it like that. It is minus 1 minus lambda, bracket close, and then equating to 0. We have to simplify this. This implies that 7 minus lambda into, you see here, minus 1 minus lambda.
Mm.
Minus 1 minus lambda means, you see here the rough column I'm doing here for this. Minus 1 minus lambda whole square
Yeah.
means we have to take minus common. So then it is
Okay.
1 plus lambda whole square. Now once if you
Okay.
do it square, minus, even though minus will also become plus. So we are left with
Okay.
1 plus lambda whole square. And then if you simplify a square plus b square plus 2ab, this value we
Okay.
have to write it here. Understand?
Okay.
This is the rough work. So I'm just for your understanding purpose I'm writing. So neglecting this all. Now moving on to our problem. A square
Okay.
plus b square plus 2ab minus 4. And now minus 2 as it is, first of all, inside multiplication. These two we have to multiply. It is 6. Again, these two we have to multiply. It is plus 6 lambda. Close it. Sorry, we have one more minus lambda 12 also. Minus 2 into, it is minus 12. This is minus into minus plus 6. This is minus into minus plus 6 lambda.
Sir, minus 12 minus 6. Minus into minus plus.
Which one? This one?
Yeah.
No, no. This 6 should multiply with these two separately. Then later on,
Yeah.
okay? This implies that I will send it to you, this recording. I will
Yeah.
send you the link of this recording. You can see there. Lambda square plus 2 lambda. And it is minus 4 plus 1 is minus 3 here. This is minus 2 into how I am multiplying, the way you just see this one. 6 lambda, first lambda value, then minus 12 plus 6 becomes minus 6 only. Then minus 2 into, see here, first I am writing lambda value, 6 lambda. Then minus 12 plus 6 is minus 6 is equal to 0. And now this one we have to multiply, moreover this one. This one we have to multiply and with this also. 7 will multiply with each and every term of these three. Understand?
Oh,
Okay, let us start. 7 say for every element we have to multiply. It's a 7 lambda square, 7 twos are 14 lambda, 7 threes are 21. Then lambda should multiply with this all. We are getting minus lambda cube term, which is one of the verification every time. Minus 2 lambda square we are getting here. Minus into minus plus 3 lambda. And then minus 6 twos are 12 lambda. Okay, then minus into minus plus 12. Minus into minus plus 12. And then minus 12 lambda. And then plus 12 is equal to 0. We have to write this in a proper order. And this work yesterday also we have done. Minus lambda cube is a single term. From 7, if you subtract 2 square terms, I'm talking about the square terms. So we get 5 lambda square. And now you see lambda terms. How many lambda terms are there? I will show you with the help of another color. Mine is 14. Sorry. This is 14 plus 14 minus 12 minus 12 plus 3. So 14 plus 3, 17. 17 minus 24. Have a calculator with you? 17
no.
minus, oh, don't have that. So this is 17 minus 24 is,
13.
yes, no, 17. These are 7. Minus 7. Minus 7. 24. From 24, we have to subtract 17. We are getting minus 7.
Okay.
And now, constant terms. Notice the constant terms. Here you see, that's a minus 21.
Mi-
It's a
Minus
12.
12.
12, 12, 12, 24. 24 minus 21 will give you plus 3. Correct?
Mm,
It
Yeah.
is given to you plus 3. It is equal to 0. Now, we have to multiply with the minus sign because we're getting minus sign. So once if you multiply with the minus sign, we get lambda cube minus 5 lambda square minus into minus 7 lambda, and this is minus 3 is equal to 0. This is taken as
Mm.
equation number 1. Do you have any doubt till here? No doubt?
No.
Yes. So this is called character. What is the definition statement? You see, every square matrix satisfy its own
Own
characteristic.
characteristics
ये है
equation.
आपका स्क्वायर मैट्रिक्स, ये है इसकी कैरेक्टरिस्टिक इक्वेशन. ये मैट्रिक्स ये
Okay.
इक्वेशन को सेटिस्फाई करना चाहिए. मतलब जहां पर भी लैम्डा है वहां पर ए रख दिए तो आंसर 0 आना. देन वी से केली हैमिल्टन थ्योरम वेरीफाइड.
Okay.
सो दैट विल बी द नेक्स्ट पेज. सो यहाँ पे लिखेंगे. सो इफ कैपिटल ए satisfies, if capital A satisfies equation number 1, then Cayley Hamilton theorem verified. Cayley Hamilton theorem verified. So it means what? Every lambda value should be replaced with a capital A. A cube minus 5a square plus 7a minus 3. A cube minus 5a square minus 7a. A cube minus 5a square, not minus, it is I think plus. Yeah, plus a plus 7a. And from this, up to minus 3, we have to multiply with the identity. 3 with the identity matrix we have to multiply and show that it
Mm.
is equal to 0. So now here in the this page I will show you what we have to do. If you have the calculator, बार बार बोल रहा हूँ मैं, इससे आपको बहुत हेल्प हो जाता था. मैं कर रहा हूँ बोल के आपको सेटिस्फेक्शन भी होता. सर कोई बात नहीं, मैं करके बता देता हूँ आपको. First of all, we need this value a square. Do you know how to do a square? A square is nothing but a into a.
Okay.
So somewhere we have to multiply this one. A value, we know that a value is 7, 2 minus 2. You see our a value is this one only. It's our question.
7, 2 minus 2. Minus
Minus
6
6
minus 1, 2.
minus 1, 2,
2.
6,
6,
2,
2 minus
1. This one we have to multiply with the same matrix. 7, 2, minus 2, minus 6, minus 1, plus 2, 6, 2, minus 1. तो फर्स्ट कॉलम से मल्टीप्लाई करना है आपको. आपके पास अगर कैलकुलेटर है तो ये मल्टीप्लाई करने का जो 2 मिनट है, 2 मिनट 1 मिनट जितना भी टाइम आपको मैनुअली लग रहा ना, वो टाइम आपके पास सीधा सीधा सेव हो जाता था. एंड वी आर गेटिंग द आंसर इज 25. कैलकुलेटर से करना है 8 minus 8. अगर आप मैनुअल करेंगे इट विल टेक लॉट ऑफ टाइम. इट इज minus
Yeah.
20 minus 7 8 minus 7 and plus 8. It is 24. It is 8. It is minus 7. This is your a square value. Now a square is done. We go for a cube. A cube is nothing but a square. ये जो काम मैं आपको अलग कलर से कर रहा हूँ, it is only for your satisfaction.
Yeah.
It is 25. It is 8. It is minus 8. It is minus 24. This is minus 7.
Minus 7.
8, 24, 8, minus 7 should multiply with a. 7, 2, minus 2, minus 6, minus 1, plus 2, 6, 2, minus. Now again from the first row first column method, if you multiply and get the value of a cube as, we're getting our a cube value is, it's a 79, 26, minus 26. मैं आपको एक वेरिफिकेशन बताता हूँ, देखिए आपको, देखिए एक चीज आप देख लीजिए, यहाँ पर फर्स्ट रो में दो पॉजिटिव एलिमेंट एक नेगेटिव एलिमेंट है ना,
जी
टू पॉजिटिव वन नेगेटिव एलिमेंट.
जी.
In this a square also, we get two positive and one negative element, means it is correct. Verification, your multiplication is correct. Even in a cube answer also, if you see two positive and one negative element, this means
Okay.
your verification, it's a correct answer. जैसा आपका
Okay.
a का पोजिशन रहेंगे एलिमेंट्स के पॉजिटिव नेगेटिव, ए स्क्वायर में भी वैसे ही रहेंगे और ए क्यूब में भी वैसे ही रहेंगे. देख लीजिए आप, यहाँ पर देखो फर्स्ट एलिमेंट नेगेटिव है, फर्स्ट एलिमेंट इज नेगेटिव या सेकंड, पहले दो एलिमेंट नेगेटिव या तीसरा एलिमेंट नेगेटिव. मैं एक यूज कर रहा हूँ यहाँ पर, देखो गेट आंसर इज minus 78, minus 25. It is a verification that you have done correctly. This is 78,
Okay.
but better to use a calculator. Minus 25. This is from minus 5 into, we have to subtract a square. A square is this one. 25, 8, minus 8, minus 24, minus 7, plus 8. This is 24. This is 8. This is minus 7. Plus, actually it should come in a same line, but यहाँ पर मैं इसको ऑलरेडी कुछ वर्क कर दिया हूँ, इसलिए यहीं पे कर रहा हूँ. This is 7 2, minus 2. It is minus 6 minus 1 plus 2. 6 2 minus 1. Minus 3 into the identity matrix of 3 by 3 order, 1 0 0 0 1 0 0
Yeah.
0 1. Now we are in the verifying stage. How to verify? The other cases. I'm using another color again. First element could be taken. Here is 79. This is
Oh,
minus 5 into 25 is 125. This is 7
okay.
7 49. This is minus 3. If you add these two values, we get minus 128. And if you add these two values, you will get plus 128. मतलब first element of this all matrix will be 0. इसका मतलब ऐसे ही अगर
Oh,
आप पूरे वैल्यूज को ऐड करते जाएंगे, ये तो जस्ट वेरिफिकेशन था, आपको सेटिस्फाई करने के लिए मैं एक और एक ले लेता हूँ. I'll take here 26 and then minus 40. Second element from each matrix. 7 2s are 14. I'm taking randomly 3 into 0 0. You can add these to verification. 40 and minus 40 will become 0. Got my point?
okay.
So it means if you simplify this all matrix, finally, we get our answer will be like that. It means Cayley Hamilton theorem verified. This is called verification of Cayley Hamilton theorem. Verification of Cayley Hamilton theorem for 3 by 3 matrix when we have 3 rows and 3 columns. If you want, I will take one more example to show you. I'll take one more example. It may be possible that sometimes you get 2 by 2 matrix also for verification to verify Cayley Hamilton theorem. Sometimes you will get a 2 by 2 matrix also. That is very easy, but I'll do it one question for 2 by 2 also.
Mm.
2 by 2 matrix I'll take. Sometimes in exam they'll give you only 2 by 2. I'll go for that exam.
Okay.
So the question will be verify Cayley.
Sir, can you go to the previous page, sir, once?
Yes.
Yes.
This one,
No. The last page.
this one.
The one which, yeah. Okay. Okay.
No problem. I will send it to you, this PDF.
Yeah.
You have to go through this. Now we are doing one more question to make this
Okay.
concept more clear. Cayley Hamilton theorem for, here we have a 2 by 2 matrix. Matrix, whatever it may be, but matrix, whatever it may be, it may be 1, 2, 3, 4, or it may be 1, 2, 4, 3, whatever it is. We have to
Okay.
verify the Cayley Hamilton theorem. Body of the matrix will change in exam. It
Okay.
may or it may not be possible that you will get the same thing.
Okay.
Not assure that the same question will come, but the pattern should be, the procedure should be same. This will, I will
Okay.
assure you. Shall we start now?
Yeah.
Solution. So what is your first step? The characteristic equation of capital A is magnitude of A minus lambda I is equal to 0. This implies that magnitude of only 2 by 2 we have. So 1 minus lambda, this is 2, this is 4. The change is only for the diagonal elements. We have only 2 by 2
Yes.
matrix. So now
3 minus lambda.
plus minus plus, no need for this also. AD minus BC is the rule. This implies that
Okay.
AD means 1 minus lambda into 3 minus lambda. It is AD minus BC means 4 to the 8 is equal to 0. I am choosing a random question. Okay. This is 1 1 za 1
Okay.
1 3 za 3. अच्छा, एक और चीज मैं आपको बता दूं यहाँ पर क्लियरली, हो सकता है ऐसा भी, सपोज यू आर फाइंडिंग आइगन वैल्यूज की बात करते हैं. इफ यू आर फाइंडिंग आइगन वैल्यूज and you are not getting the roots here like that, sometimes you are not getting the roots means your eigen values are the complex numbers. In that case eigen
Okay.
values does not exist. अगर आपके eigen values
Okay.
लैम्डा के अगर कॉम्प्लेक्स में आ रहे, यानी कि रूट्स में आ रहे, जिसके अपन
Okay.
रूट्स फाइंड आउट नहीं कर सक रहे, सो देन वी से eigen values exist but eigen vectors does not exist. 3 1 are 3 minus
Okay.
lambda minus 3 lambda minus into minus plus lambda square minus 8 is equal to 0. Better to write in order. Lambda square minus 3 lambda minus lambda is minus 4 lambda. From minus 8, if you subtract 3, you will get minus 5 is equal to 0.
5.
Equation number 1. अब क्या लिखेंगे? What to write? If capital A, if capital A satisfies, if capital A satisfies equation number 1, then अच्छा क्लास क्या होना बोला? थोड़ी देर वेट करना पड़ेगा, हाफ एन आवर. मैं तो कल मॉर्निंग 9:30. Then Cayley Hamilton theorem verified. If A satisfy equation number 1, then Cayley Hamilton theorem verified. Means here just plug A with lambda. Replace capital A with lambda. A square minus 4A minus 5 Whenever constant is there, we have to multiply with identity matrix is equal to 0.
I.
A square. This work we can do it somewhere here in the rough column. Okay, and
Mm-hmm.
then here we can plug it and I'll show you very easy way. A square also I'm doing. So I think I should use some other color so that you understand it is or separate area A into A, which is equal to 1, 2, 4, 3 into 1,
2, 4,
2,
3.
4, 3. First row, first column method. It is equals to 1 1s are 1 plus 4 2s are 8. 1 plus 8 is 9. 1 2s are 2 plus 3 2s are 6 means 8. 2 1s are 2 plus 3 2s are 6. 4 1s are 4 plus 4 3s are 12. 12 plus 4 is 16. 4 4 2s are 8 plus 3 3s are 9. 8 plus 9 is 17. This is a square. That's it. Just plug it here. This implies that a square value we got it. 8, 9, 16, 17
Sir,
minus.
in multiplication,
Yeah.
uh, we are doing a square is equals to a into a. In
Yeah.
a into a, can't we just multiply 1 into 1
No, no, no. We
and
have to follow the rule. That's what I am discussing. That first class में मैं आपको matrix
which rule we are following, sir, here?
I'll show you. I'll show you in detail. If you ask me the doubt, I'll show you in detail. See, I will do it in detail. You should ask me. I will be very happy if you ask me the doubt.
Okay.
So the rule is this one. 1 multiply with 1 plus 2 multiply with 4. First row, first column plus A.
Oh,
First row.
yeah.
I have shown this one, no?
Yeah,
Already
yeah,
in the
no.
first class, we are discussing this only.
Yeah, yeah, yeah. Like it's like first row into first column.
That's it.
Yeah, yeah.
Actually, this is for 6th class, 7th class student. That's what I am writing direct answers.
Uh, now I
So
can do that, sir.
let us complete. 8 plus
Okay.
1 is 9. 6 plus 2 is 8. 12 plus 4 is 16. 9 plus 8. 8 plus 8, 16 plus 1 is 7. This value we have to put in place of a square. Now got it the idea?
Yeah.
This is 9. This is 8. 16. This is 17. Now a with 4 minus this minus sign as it is. Every a with the 4. 4 से हर एक a को multiply करेंगे. This is a. 4 1s are 4. 4 2s are 8. 4 4s are
8.
16. 4 3s are 12. What I am
12.
doing? Every element of a should be multiplying with 4 minus
Yeah.
identity matrix is 1001 multiply with 5. 5005.
5005.
Now you see the verification. The final answer should be 0. Let's verify. 9 here first element minus 4 minus 5. Now 8 minus 8 minus 0. 16 minus 16 minus 0. 17 minus 12 minus 5. Look at the answer. The answer is 9 minus 9 because these two are again minus 9. 9 minus 9 0, 8 minus 8 0,
0.
16 minus 16 0, 17 minus 17 0. It means we
0.
say that the Cayley Hamilton theorem verified.
Yeah.
Sometimes in the exam they may ask something extra, but one thing I will do it. अगर मैं आपको नेक्स्ट हाफ एन आवर थोड़ा एक क्लास आप एंड अप कर देंगे नेक्स्ट हाफ एन आवर में नेक्स्ट करेंगे क्योंकि अगर मैं 40 मिनट कंटिन्यू करा तो 10 मिनट्स का ब्रेक दो बोल रहा हूँ
Okay, ठीक.
अभी अपन एंड करके फिर इमीडिएट नेक्स्ट मीटिंग कर सकते
Okay.
हैं ओके ये बोर्ड और ये रिकॉर्डिंग आपको सेव हो जाए
Okay.
ठीक है ना आई सेंड यू द इमीडिएटली इन द नेक्स्ट मीटिंग लिंक